we have a string S, which is CBAEFD, and then we create a visited array for each vertex. We mark them as a false. And then we try to iterate every vertex for vertex in the string S. We check every vertex whether visited as a vertex is false or true. If it is false, that means it's never been visited before. If never visited before, then we can form a component. We will create a list, characters, and indices to record connected component. Then we can try to do depth first search for the vertex 0. The node 0 had one adjacent node, which is 1, and we do depth first search for 1. And 1 have 2 adjacent node, which is 0, but 0 is visited before, so we check another adjacent node, which is 2, and we try to do depth first search for 2. But 2 have an adjacent node, which is 1, but 1 is already visited, so we finish depth first search at 2, and then we finish depth first search at 1, and then we finish depth first search at 0. So in this case, we append the indices 0, 1, 2 into the indices list, and then we find the corresponding characters in the S array, which is CBA. We append them into character list, and then we mark the visited array, which is the first 3 elements CBA. All of them is true, 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 become visited. And then we try to sort the characters list, become ABC, and we try to sort the indices list, become 0, 1, 2, and then we create a new array, which is answer. It have a 6 empty element, which is a character string, the same as the S string. And then we try to find the index in the characters list and in the indices list, and then we try to use a for loop to iterate every character in the characters, and then we use the indices list to find the corresponding position, which is the indices at index. So in this case, we first write A from the characters list. So for the same reason, we can get our result, which is A, B, C, D, E, F, and then we try to concatenate them into the same string, which is A, B, C, D, E, F. First, we create a class solution, and then we define our function smaller string with the swaps, which have S argument and pairs, and then we create a variable answer, which is an empty string array, and multiply by the length of S. And finally, what we want to get is to return the answer. And now, let's iterate over the indices from 0 to S store size -1. So for each index vertex, if the vertex is not visited yet, that means the visited at the vertex is false. At that time, we can perform depth first search. We create a new array, visited, and we put n elements, all of them is false, into it. So it can use to track the visited vertices. And the visited array, it is required size of O of V space. If that vertex is visited, we just try to skip it, but if that vertex is not visited, we try to do depth first search on it. We create an empty array characters, and we also create an empty array indices. In the worst case, the indices and characters will take O of V space. And then let's try to call depth first search, which involves the argument S and the vertex, and the list characters and the indices. And then let's go back to the beginning in the class solution. We try to define the depth first search, which we should add another argument of self. While we perform depth first search, we just store in the vertex in the list indices, and the characters S at vertex is in the list characters. We add the character and the index of the current vertex to the characters and the indices list respectively. So in the current connected components, the characters list contains all of the characters of the vertices, and the indices list contains all of the indices of the vertices. So these lists are later used to store the characters and the indices, and we just store them in the answer array. And then after we visited that vertex, we just mark the visited at vertex is true, and then we try to use a for loop to do our depth first search for the adjacent vertex in the adjacent list, and we should use this list. And then let's go back to the last function. We try to create a new array, which is adjacent list. It is a 2D array, which is an empty array multiplied by the length of S initially. We iterate over the pairs and create an adjacency list which take O of E space, such that adjacence at source contains all of the adjacent vertices of vertex source. So when we build in the adjacency list, we use the pairs it given for each pair x, y. We add an edge from x to y and from y to x. So this we try to build an adjacency list. It takes O of E operations as we iterate over the list of pairs once, and we inserting the element into the adjacency list. It takes O of 1 time. Then we will iterating over the indices from 0 to n-1, where the n is the length of the given string S. So during the depth-first search traversal, each vertex will only be visited once. This is because we mark each vertex as visited as soon as we see it, and then we only visit the vertices that are not marked as visited. And when we iterate over the edge list of each vertex, we just look at each edge once. So these have a total cost of O of V plus E time, and also the runtime stack for depth-first search will use O of V space, and just one active function call for each vertex. And then we sort the list indexes and characters, and we iterate over the indexes and characters and place the ith character at ith index in the string, smallest string. Because we store the list indexes and the characters for the components, so in the worst case, all of the vertices in the graph belongs to the same component. In that case, we have to sort in 2 lists of V elements, which will take O of V multiplied by log of V time. The additional space is used for sorting the list indices and characters, so the space complexity of sorting algorithm is language specific. For instance, Java use arrays.sort for the primitives is implemented as a variant of quicksort algorithm whose space complexity is O of log of V. But in the C++, it uses sort function, which is provided by standard template library. It is a hybrid of quicksort and heap sort and insertion sort, but in the worst case, its space complexity is still O of log of V. In Python, the built-in sort method for lists uses team sort algorithm, which is a hybrid sorting algorithm. The team sort has a worst-case space complexity, which is O of n, which means that it requires additional space of O of n for the sorting the list. So team sort is a stable. And then let's iterate our character in the characters list. We just assign every characters in the corresponding index into the answer array. So we get our answer and we try to print them out, but we should first print solution.smallest string with swaps, and we input our input example, and it is a separate string, so we have to concatenate the answer array. Now let's print out. Yes, that is correct answer. And now let's analyze the complexity. The total time complexity is equal to O of E plus V multiplied by log of V, and the total space complexity required is O of E plus V plus log of V. So hence, the space complexity is equal to O of E plus V, and here the V is represent the number of vertices, which is the length of the given string, and the E, which is represents the number of edges, which is the number of pairs.